Hi, this is Trevor from the 3D Applications team. In this tutorial, you will learn how to navigate the Python console in Avizo and Amira, and use Python to interact with Avizo and Amira modules. It's my goal in this tutorial to show you a process for developing Python code in Avizo and Amira that enables you to be creative, inquisitive, and self-sufficient. This tutorial also assumes you already have a basic understanding of Python, which you can gain from following many tutorials found on the web. So let's begin. Navigating the Python console in Avizo and Amira. Show the console panel and switch to the main Python console tab. You can enter standard Python code into the prompt interactively. Let's define a list of numbers as a variable. Then we can calculate the sum of those numbers, for example. Sum is a function included in the standard Python library. In addition to the standard library, you can also import many popular Python packages for use in Avizo and Amira. The list of importable packages can be found in the user's guide. For example, we can use NumPy to calculate the square root of each item in our list of numbers. You'll notice that we include an autocomplete feature that helps you navigate Python's packages, classes, and methods. For example, all of NumPy's functionality is exposed if we type our variable for the NumPy namespace followed by a period. There are also two buttons available at the top of the Python console. The X will remove objects created by this instance of the Python interpreter. The X with stylized lines of code beneath it will also remove all objects from the interpreter and then completely clear the console. Let's do that now to prepare for the next section of the tutorial. Using Python to interact with Avizo and Amira modules. Let's look at how to approach a common Python use case in Avizo and Amira, automating some interactions with modules in the project view. In this example, we'll use Python to visualize the neuron.am dataset, which can be found in the Data Tutorials Neuron folder of the installation directory. We'll design our script to create an orthoslice and attach it to a dataset, which is something that Avizo automatically does for us when we open it because of the auto display feature. Then we'll change the color map to physics. Then we'll adjust the color map to a more appropriate range. So how do we even begin this? The most important classes for interacting with Avizo and Amira begin with hx_. Type this into the console and you'll see a few classes. The hx project class allows the user to interact with the project view. If you access it with the period, the auto-completion results show the methods available in that class. We see a create class, and that's what we'll use to create our orthoslice. So hold up, you might be thinking. How would I know that unless someone told me? How could I have possibly learned that on my own? This is where the help function comes in handy. We can pass the name of any class, method, or function to the help function to see its documentation, complete with examples. Here we see the documentation for the hx project class, which, in turn, contains the docstrings for all of the methods in the class, including create. Alternatively, we can pass the name of a method to the help function as well, and see just that method's documentation. Note that example code is included in the documentation. We see that we can pass a string to create with the type name of a module to create it in the project view. Each module has its own type name, or the name of the class that we use to refer to modules internally. This is required to create the module in Python, but how can the user find it? It's easy. You can find the module in the Object pop-up menu, and the type name is right there in the pop-up. Alternatively, the user can use the get method of the hx project class to see information about a module. So now that we've seen the documentation for these methods, let's finally write some code. Go ahead and delete the orthoslice if one was created when you opened neuron.am so that we start with a clean project. We'll create our own orthoslice using the create method and assign the created orthoslice to a variable for easy reference in the future. And now we see our own orthoslice in the project view. However, it's unconnected. We need to manually make the connection to the dataset we want to visualize. Just like hx project, our OrthoSlice object has its own methods and attributes. We can see how to access the ports, or the different options in the Properties panel, by entering the OrthoSlice's variable name and hitting return. This prints some information about our object, including the names of available ports. Alternatively, we can use the port names attribute of our OrthoSlice object to display the ports as a list. The first port name in the list, data, corresponds to the data port we see in the OrthoSlice's properties, which controls the dataset that the OrthoSlice views. To access this, we need to use the data port's connect method and pass the handle to the object that we want to connect it to. Let's do that now. Note that since our dataset's handle has not been assigned a variable, we can't just pass its label to connect. We have to first get its handle using hxproject_get. Modules have a built-in method called fire that apply the changes to properties and activate the changes in the Avizo or Amira-GUI and viewer. It's recommended to use fire to apply data connections before changing any other properties. We can apply this now. After this, we are ready to apply the other changes. Remember that we still need to connect the OrthoSlice to the physics color map, and then adjust the color map to the histogram range. Color maps are loaded as hidden data objects in the project view, and you can right-click in the project and choose Show Object to see their names. We see that physics is actually loaded as a separate dataset called physics.icall. Knowing this, we can connect the color map port to physics.icall the same way we connected it to the data port. And finally, we can use the range attribute in the color map port to readjust the histogram. If you don't know what methods or attributes belong to a port, remember that you can explore that using the auto-completion menu or by sending the port to the help function. Remember to use the fire method to apply changes to module ports. So by now we've accomplished our goal. It's a good idea to build up a script as you work, with each successive line of code that does what you want. That way, by the end of your process, you have a cohesive script already put together so you can quickly use it again in the future. The simplest way to do this is save a file and copy and paste the code. Before pasting the code, let's clear the project so that we see the results clearly. Note that after deleting our OrthoSlice, it's still visible in the viewer. That's because if a module is also linked to the Python interpreter, it will sometimes still exist even after deleting it in the project. This is why we have to also clear the Python interpreter using the X button that I described earlier. Now, once I paste my code, I see an error message with some feedback about what the error may be. This feature enables me to debug my code. In this case, the string representing the name of my data object is not recognized because I have used an incorrect character for single quotes. I can fix this in my save pile, then recopy and paste the new code. It worked! But this is not the only way to reuse code. Note that for this script, the only input that the user might need to change to do this for a different dataset is the name of the data that they want to visualize, and then the minimum and maximum of the new color map range. Python has a mechanism for defining a function using the def keyword, which can accept an Avizo or Amira data handle and float numbers, or anything else really, as arguments. After this function is defined, the user can execute all of that code with a simple single-line command. So as a summary, you've learned how to use the Python console in Avizo and Amira specifically to interact with data objects and modules in the project view. I hope that you're also comfortable using the functionality we've included to help you learn our own flavor of Python for your purposes. Goodbye, and thank you for viewing the tutorial.